Hi, good afternoon, everyone. Within biofuels, I'm going to talk about sustainable aviation fuel. So, this presentation was supposed to be made by my colleague Dr. Monica Normark. She couldn't travel here, so in her place, I'm making this presentation. Before I start, I would like to talk about KBR. Within KBR, KBR is a more than 100-year-old company based operating out of Houston. We offer technologies under various domains: clean ammonia and hydrogen, refining and clean fuels, petrochemicals, inorganic chemicals, plastic recycling, proprietary equipment, and catalysts. All our technologies are based on these four important pillars of energy transition, decarbonization. All our technologies are based on these four important pillars of energy transition, decarbonization, biofuels, and plastics recycling. We offer something like 75 plus process technologies in our entire portfolio. Coming to this sustainable aviation fuel, why it's important today. According to IEA, International Energy Agency, globally 2% of global energy aviation accounts for 2% of global energy related CO2 emissions in 2022. And that's why you see the countries around the world, they have started working on reducing these global emissions. If you take the case of India, recently India test flighted a flight with 1% blend in sustainable aviation fuel. This was received by the minister early this year. And Government of India plans to make a 1% blend in sustainable aviation fuel mandatory by 2025. Same thing is happening across Europe. European Union plans to make 2% compulsory blend in of sustainable aviation fuel into jet fuels by 2025. This 1% or 2% can go up to 4% or 5% depending on the availability of the of biofuels and supply. With this, let me talk about these sustainable aviation fuel challenges and opportunities. So when we talk about sustainable aviation fuel, there are a couple of things which are very important. One is about drop-in. So drop-in is basically a concept which means that the aviation fuel that we are going to use, is it a blend-in or drop-in? Blend-in basically means, has it to be blended with the available jet fuel? Has it to be blended with jet fuel to make it viable, make it meet the energy criteria? Or can it be a completely drop-in fuel? That means, can it exactly replace the jet fuel properties? Can it copy the jet fuel properties? So that is what drop-in means. Second one is ASTM certification. So ASTM is responsible for certifying the production of jet fuels and how and if it can meet the aviation industry requirements. So ASTM certification is a long drawn process. It takes 3 years to 5 years to meet the ASTM certification requirements. Any new process technology has to go through it. Next one is about biofuel feedstock and scalability. Do we have the sufficient biofeed available to make biofuels? You might have heard that companies are making biofuels from used cooking oil. I mean, waste oil from French fries. That looks very attractive, but do you have sufficient supply of this kind of feedstock? Perhaps the answer is no, but it looks good to talk about. So when we talk about sustainable aviation fuel, we have to look at the availability of feedstock, biofeedstock. The next one is about process technologies. So to make the sustainable aviation fuel, there are globally 9 process technologies available. These process technologies are known as pathways. So pathways from converting either 1G, 2G or 3G ethanol or biofeedstock to the aviation fuel. Out of these 9 pathways, 2 are co-processing being produced from the petroleum refineries, and 7 are purely bioprocesses. Next one is about proven operating plants. So if you're talking about any technology in the aviation fuel, is the technology proven? Has someone tested that technology? So these are 5 important elements that we have to consider when we are talking about challenges and opportunities in the sustainable aviation fuel segment. With this, I would like to introduce the technology that our company offers. It's branded as Pure SAF, Sustainable Aviation Fuel Process Technology, and this technology was developed by Swedish Biofuels and it's globally licensed by KBR. Swedish Biofuels has developed this technology over a period of 20 years. they have developed this technology over a period of 20 years. They have got an operating plant based in Stockholm. Before I delve deep into the PureSAF technology, there are three things that I would really like to especially like to highlight. This technology, the fuel produced by this technology, has been used by U.S. government, has been used by U.S. Air Force and Navy through its DARPA program. And this has been used like 100%, the flights are operated on 100% fuel using this technology. Just compare it, like we are talking about fuel being used as 100% replacement fuel versus what we tested in India, like 1% blend in. So the technology that we are offering is tested technology by the US government. This is technology ASTM certified. As I said, the ASTM certification process is 3 to 5 years, and Swedish Biofuels spent almost like 8 years to get the certification. The pilot plant that we have is running at a capacity of 30 tons per annum, and this plant has been operating continuously for 55,000 operating hours. At one instance, this plant ran continuously for like 2.5 years continuously. That was one of the requirements for ASTM and by the US for the DARPA program. Talking about Swedish Biofuels and KBR. So Swedish Biofuel is a technology developer and owner for this technology with 20 plus years of R&D experience, and they have got 130 patents around this around this fuel technology. Their processes are like ASTM certified, plant in operation since 2009, in continuous operation, and they were commercial demonstration approved and tested by US by DARPA program. Talking about KBR is a global licensing partner, has been operating for more than 100 years, and we are a AAA rated by MSCI. We offer 75 plus technologies, and we are known for taking lab scale plants all over the world and doing some doing engineering work to take it to commercial scale. So we are a company which is known for taking lab scale plants to a commercial scale plant through our engineering efforts. PureSAF technology development process, they started way back in 2003. They have gone through several processes. I'll not go through this slide. Now the technology that we offer, it's 100% drop-in fuel. It can replace the jet fuel exactly without any kind of need for any kind of blend in. About KBR, from KBR we offer several technologies. Just to highlight few things, I mean, next year 2024 we are going to complete 100 years of our offerings within refining sector. For FCC was KBR was one of the pioneers in developing the FCC technology, which is the main technology for producing gasoline, for producing petrol. Similarly, we have got several other technologies. This is our entire technology portfolio. Yeah, as I said, we are completing 100 years next year for our refining portfolio. Why PureSAF? As I said initially, there are 7 routes for producing aviation fuel, the thing that we call as pathways. Out of 7 pathways, there are some pathways for which technologies are mature, but they don't have future scalability, or there are certain other limitations for other technologies. It started with Fischer-Tropsch process, and then it moved on to HEFA, then it moved on to other routes, SPK and SKA routes. But the other technologies, as I said, they have got certain limitations in terms of scalability. The technology that we are talking here, it's future-proof and can and does not require additional hydrogen. For example, it can run purely on power to liquid basis as well. This is our technology overview, the technology process map. If someone needs, I can go into more details, but this might be too technical for today's discussion. Same thing here. So this is about ATA, alcohol to jet, SPA, SKA, and SPK route, and we can produce aviation fuel with or without aromatics as per the requirement. This study was done by DARPA under one of the programs to see the quality of the fuel being produced. How is the molecular distribution of the aviation fuel that we are producing as compared to the molecular distribution of jet fuel produced from fossil fuels? It is exactly the same in terms of molecular composition. and that defines why our technology is future proof. Again, to repeat these three things, the technology that we are offering, it's capable of operating on a variety of feedstock. It's one of the most credible pathways to net zero, 100% sustainable fuel with or without aromatics, and fully ASTM certified. So that's it about our technology that we offer. If you got any questions, I can answer it now, or we can take it up later. Thank you so much.
Well, I think what it turns out is commercially, for a country like India where food is an important factor, and the transport minister had said about 1% being mandated and increasing it to 5%. But at the same time, he is forgetting that the growth of food grains in India is about 2 to 3%. If out of the 2 to 3% increase you dedicate 5% towards the aviation fuel, there is going to be a conflict between the food and fuel, which needs to be leveled, which needs to be sorted out.
That's based on the assumption that we are operating only on 1G ethanol. If you start operating on 2G ethanol or 3G ethanol, the economics changes completely. 2G is like...
No, you see, it all depends on where you get the basic ethanol. First is ethanol, from where we produce it. If it is from fossil fuel, back to square one. If you are producing it from agro-based material, the trouble is again fuel and food. So, for a moment, you can say E1, E2, E3, E4, E5 up to E17. But the basic E is from food. It has a bearing on food. Or fossil fuel from where you extract through fractional distillation, as I said. You obtain a series of ethanols, methanols, and butanol from the fractional distillation.
So 2G ethanol is about producing ethanol from waste food products.
From?
Waste food products. So like, for example, from a rice husk or a corn web or those kind of things. So it's from the waste food products, the ethanol being produced, crop residues. So if you're producing ethanol from crop residues, then that changes the economics completely. As you said.
Correct. But then collection of that food waste.
Crop residues, sir, for example, in Punjab, for example.
Yes, from the crop residue, the ethanol that you manufacture from the crop residue.
Yes, sir.
Can give you the base for.
Yeah, so that's why our technology can take the 2G ethanol or the crop residues, and therefore this technology is more scalable and more future-proof.
By the time you reach aviation fuel, what is the cost that we have added on it?
I'll give you an example of plastics. So a couple of years, even 3 years back, when you were talking about plastics from renewable sources, no one believed that plastics from renewable sources will be sold in the market, even in the India market, because plastics from renewable sources, the cost is high. But what has happened in the last 3 years, including India, I mean developed countries of course, people have started buying plastics which have been produced from renewable sources, although the cost is high. Even for example, if you go to buy any sports T-shirt, these sports T-shirt, they have got carry a label that made from renewable plastics, renewable T-shirt, and we are paying a premium on that. So, and 3 years back, no one thought that people will be paying premium for renewable plastic, but we are doing it now. Same thing is going to happen in this aviation fuel sector. I can give you examples from 2 major airlines of the world. If they use sustainable aviation fuel, increase the prices, then they are talking to corporates. According to a research, according to their survey, corporates are willing to pay a higher amount per ticket if their people, employees are traveling on an airline which is using sustainable aviation fuel. And that's happening now.
Well, that's good if there is if the conflict between the food and fuel is not there and can be based on the agriculture, what you call as the
residues,
food grain crop residue.
Yes, sir.
And that too within a manageable cost range.
Yes.
Then it's doable. And secondly, I think it will be the best to put to a best use during a war-like situation when there is a constraint on the import of gasoline or the jet fuel. There it can be a good substitute. But again, because at that time cost is not the consideration is the availability and domestic availability. So there, yes, it is going to be a big help.
It is.
Now, may I request Mr. Sharma to, yeah.
Yeah, basically, you are talking about the 2G ethanol that comes from the agro waste, right? Agro residue. So, can you please tell me that what about the percentage production yield of ethanol from this agro residues? Kind of.
More than percentage production, here we also count about how much is CO2 being generated in the complete process. As per some studies, if I remember correctly, around its advantages to the tune of almost like 80%. I've got some studies available with me. I can share it with you separately. But
Okay.
as compared to as compared to fossil fuels, its advantages is up to 80%.
Yeah, I know that, but you know that ethanol, the 2G bioethanol, so what kind of process you are using? Is that enzymatic, is that a biological pathway or thermochemical pathway?
It's a mix.
Yes,
Yeah,
it's a mix,
yeah,
okay. Okay, understand actually. Actually, I'm working on that field, that is why I'm asking on it.
Yeah. Uh-huh.
Okay.
You are from?
I'm from IIT Kharagpur.
Okay, sure.
Okay, thank you.
Thank you.